Okay, so who managed to draw a diagram? Okay, so in geometry, who used a ruler? Okay, one person. So in geometry, you'll want to always use a ruler and a compass. In fact, who doesn't have a compass? Get a compass.
But maybe I can try to solve.
Yes. Okay. So in geometry, one of the most important things is to have a good diagram. Having a good diagram pretty much like helps you see stuff. So if the question had a square and you draw it like this, right? You wouldn't you see this as like, would you remember that all these sides are equal? Like probably not. And you wouldn't remember these 90 as well. And that could be really important in your question. So that's why it's best to always try to draw with a ruler and a compass accurately. That being said, let's move on. Yep, okay. So
Question 1.
So this is your diagram pretty much, right? Yeah. And you start with this diagram and you're like, what do I do? There's not really much to go off other than this thing. So we're gonna think about nice things that right angle triangles have. Maybe compared to circles. Oh, we also know AC equals 2. So immediately, can we draw anything from this? Like just if you look at the diagram, like how could we use this nicely?
I just said that MBN equals ABC by SAS similarity.
Ooh, okay, so how?
Because they both have the right angle B.
Yep.
And then and then MN equals 2MN equals AC.
2MN equals AC. Okay, so that's one angle, and that's one side.
And then I wrote suppose that M and N are mid.
Okay, yeah. So this is one important thing. Okay, all right. So let me keep on. So I suppose. Yep.
And so I decided to give values to the lines as well.
Sure.
AB equals 6, BC equals 8, and AC equals 10.
AC equals
10.
10.
And then AB is 6 and BC is 8.
Okay, so are we allowed to do this? This is the question. Like, is this the exact right angle triangle you're always going to get? No, right? So the idea with geometry is it's going to be like, you want it to be true for any like triangle, not just a specific case. Specific cases can help you with stuff, but most of the time you want to do for a very general case. So that means generally you don't want to label any exact lengths. So because if you do this, right, you notice that fixes the triangle. Yeah. And well, if you fix the triangle, you're not solving for every single case, right? So for example, if I told you to prove something for a quadrilateral, are you allowed to assume that it's 4 just 6? No, right? So like it's obviously like you can't do this. So generally, you probably aren't allowed to do that. Yeah. So just like things to know is a lot of things are going to be general. Neighboring sites will help you like see stuff, might help you see stuff, but it might not necessarily help with solving everything. Question? Yep. Sorry, you guys. Okay, you guys. And is diagonal. So could you elaborate on what that means?
Because triangle MB and is diameter of
BMN. I see that. Right. So what he's saying here is a diagram. It's a nice configuration that it's good to know. So if you have a right angle triangle, then your MN is the diameter of the circle. So can anyone who doesn't have it, can anyone who hasn't seen this before see why that might be true? So an easy way to do it is, are you guys aware that at the angle at the center of the circle is twice the angle at the circumference? So a way you can do this is just for this. So okay, for this x and y, then you know that this is x, this is y, and then this is 2x and this is 2y. Everyone see that? Cool. So what that means here, if the angle at the arc is 90 degrees, what's the angle at the center? So it's twice 90, which is 180, which is why this is the diameter. Right? That's okay. So okay, that's cool. But knowing this, where else can we use this on this diagram? Yep.
BK is
Nice. Okay. So can everyone else see why that might be true? BK. So you see. All right. So if you just look at it, once again we apply this thing, but this time to this triangle ABC. So if ABC is a right angle triangle, then AC is the diameter of the circle. Right? Now, where is the circumcenter of a circle? It's on the midpoint of the diameter, right? So the circumcenter is where every point on the circle is equidistant to the center. So that, and we know that this is the diameter, so the midpoint of it must be the center of the circle. So this is one of the tricks that I don't know. This is one of the nice tricks that you can do whenever you see a right angle triangle. You can know that the midpoint of the hypotenuse is equidistant from every single side. So that's when you see right angle triangle, you might want to use, and you have a midpoint, that's probably what you're going to be using. So that being said, we have this. Okay, so how can we use this? Anyone else other than, sorry, what's your name? Anyone else other than George have any ideas? No? Okay, George, go.
triangle AKB.
Triangle AKB is also good, and that's because yeah. So I still want someone to say something about this. Right? how else can we relate? We have that mn, 2mn is AC. What else is, what other 2 times something is also AC? Yes, what's your name?
So AK and KC.
Yeah, AK and KC, right? So 2
And
AK is equal to AC, right?
also BK.
Yeah, so, and using what we learned from George before, we have that from this we get BK, 2BK is equal to AC. Now, how can we use this together? Like, what's something nice we can do to get do with these 2? So, look, we have an AC here and AC here. Oh, look, that means these 2 must be equal as well. So, BK is equal to M. Now, okay. So, if we simplify that, what does that like realistically mean, right? It means on a circle, we have a diameter and we have another chord, and this chord length is equal to the diameter length. What does that mean? Good.
It's also that.
Yeah. So if you think about it, right, the longest chord in a circle has to be the diameter, right? If you just draw the like, does it like intuitively make sense to everyone that it would be the longest, right? So that means BK is also done. Nice. Okay, so now we can redraw this slightly more. So that's okay. So if BK is also the diameter, what does that tell you? What more does that tell you?
B and K.
Oh, okay, yeah, nice. I didn't think of using that, but yeah, that'll work. This is a rectangle. So, oh, okay. Yep.
I think we will be using the rectangle.
Hmm?
Well, I use the one method, so one.
Oh, nice. Okay.
Yeah. So let's just let's see.
Oh, by the way, does everyone see why it's a rectangle?
Yeah.
Alright, cool. So this is diameter, so then these 2 are 90 degrees, and this is also diameter, so these 2 are 90 degrees, so everything's 90. Okay. Yep. Do you want to finish it?
So let's just call MK length Y and M.
NB. Wait. So could you say that again?
So just call MK length Y and NB.
Y and S. Is that right?
Yeah.
Yeah. Okay.
And so then that means like BN is also Y and NK is also X.
Okay.
And let's just call KC is Z. Length Z, KC.
Yep.
Yeah, and
Yep.
that also means MN is equal to Z.
MN is MN is equal to Z. Yep.
And that makes so triangle like angle KMA is also a right angle. So that means MA is also equal to X, and also that would also make angle CNK a right angle, and that makes NC Y.
So does
So that means M is the midpoint of AB and N is the midpoint of BC.
Yep. Okay. Just do. Yep.
Let me just use congruence just like all the time.
Yeah, just like the point is like they have to prove that MBN and ABC are similar, so then you can use like the 1 to 2 ratio.
Yeah. Okay. So I'll just quickly go through what everyone just did. So I think we all use some form of similar triangles. So in the sense that we have here, we have that this length and this length are the same as this length and this length, and we also have that this triangle, they're both right angles, which gives you that this and this are equal. So that was one of the solutions, and a very similar solution is to just apply it. So given this, you can see that this is a right angle, and this is also a right angle, which tells you that these two are parallel. And that parallel lines tell you that these two triangles are similar. Similar means that, and since it's we know that this is z and this is 2z, we know that the ratio is 1 to 2, and that gets you that this and this are also equal. And in the same way, that gets you that this and this are equal. So these two are the midpoints. Cool.
Questions? Yeah, I guess if you're not sure why a circle, so these are pretty useful things to know, yeah, for the future.
Yep.
So that's more general, and you can actually just specifically do it for this case as well. Yeah.
So this is a very important thing to know. And one thing you can notice from this, I guess, is that, so if I just told you that this angle is always going to be like twice this angle, right? So it's 2. And like, if I fix these 3 points and I move this around the circle, this angle is always going to be the same, right? So what does that tell you about this angle? If I moved it like here, or like here, what does that tell you? So, because by what we said before, this is always going to be half of this angle, right? And since this angle is always the same, that means that these angles are all actually all the same. And if you encounter circles and you don't use this, I'll be really surprised. So this is like one of the things that if you see a circle, it's always going to like use it. And since like 90% of your problems are going to have circles, you're going to use this in 90% of your problems. So just keep that one in mind.
Yeah, I guess you call it like the bow tie theorem.
And yeah.
I think like three of you know it, 2 of you probably don't. And then of course, when you get into this case, the proof changes slightly, of course.
So obviously here you can't just do this again, right? Because, well, it's not in between. But the same, you can do a similar idea, and you'll realize that. Any questions?
All right, excellent. Thanks, Ivan.